Tonight's lesson is, what's the rule? So, in algebra lately, we have been talking about functions and rules, and I'm noticing that our class is really good at filling out the tables, like input-output tables, but figuring out the rule, maybe not so much, and that can affect how we fill out an input-output table as well. Let's take a look. In honor of my 8th anniversary of playing a punk rock show, since 8 years ago today was my very first show with I Am Ghost, I've made up a story problem. A ticket to an I Am Ghost show cost $20. The website Ticketmaster charged $3.25 for a transaction. My friend bought 4 tickets. How much did she pay? So, we need a rule. Maybe one thing that we should do to start with is underline important information. $20 per ticket, $3.25 for using the website, that's a transaction, and then 4 tickets total. So that should give us some information. Our rule to figure out how much tickets are going to cost, if we use the letter T for ticket, would be $20 times however many tickets we get, plus that extra charge of $3.25. And just because I like the way it looks, let's put that in parentheses just to show that the $20 times the ticket, even though it would be right with PEMDAS, that goes together. So we should be able to plug it in. If my friend bought 4 tickets, we can use that rule and figure out how much 4 tickets would cost. So 20 times the number of tickets, or 4, 20 times 4 would be $80, plus the $3.25 brings us to a grand total of $83.25. Now we can use a function table to figure out how much different amounts of tickets. We can plug in our total cost for 4 tickets, and we can work backwards and forwards from there. If my friend were to have bought only 1 ticket, that would mean that 1 would be the value of T. So 20 times 1 would just be 20, and then the service charge of $3.25. If my friend bought 2 tickets, that would mean that T is 2. So $20 times 2 would be $40, plus another $3.25. $43.25. If my friend bought 3 tickets, that means that 3 is the value of T. So $20 times the 3 tickets would be 60 tickets, plus that Ticketmaster charge of $3.25. 5 tickets, 20 times 5 is the power of 100, plus $3.20. And 6 tickets would be $20 more than that, which would be $120.25. So this makes a really nice setup of basically coordinates for a graph, so that you could have a graph of how much those different ticket prices would cost you. Let's try another rule. Brian and I recently saw Wicked at the Ann Morrison Center. It was awesome, but tickets were $75 each. Ouch, that's a lot of money. And we got hungry, so at intermission we bought cookies at the concession stand for $1.50 each. So, I'm not going to tell you how many cookies we bought, but I'd like you to use a function table and find a rule to figure out how much we would have ended up dropping that night, depending on how many cookies we bought. But before we can complete a function table, or an input-output table, or a ratio table, we need to figure out what's the rule. So imagine yourself in this situation. You pay $75 to get in the door, and then you get hungry, so at intermission you have to rifle through your wallet again, and then shell out another $1.50 for every cookie that you buy. So think of it like this. You've got $75 that you already paid, plus the cost of however many cookies you bought, which is $1.50 times, let's use C for cookies, however many cookies. So our rule is $75 plus $1.50 times however many cookies we got. And that would just be for one of us, because each of our tickets was $75. So for one of us, let's check it out. So we can set up a function table, input, output table, ratio table, and we can start with 0. Say I hadn't gotten any cookies. Then my total cost would just be the $75. If I got 1 cookie, that means I paid $75 to get in the door, and then I paid an additional $1.50. So C would be 1. So 75 plus a... If I was slightly more hungry and I got 2 cookies, that would mean $1.50 times 2 cookies plus the 75 that I originally paid. So $1.50 times 2 would be exactly $3 plus the 75 that I paid at the door. Go ahead and finish this table, and then you can check back to check your answers. Press pause now. All right, here they are. So when we plug in 3 cookies for our value for C, we get $79.50. When 4 is C, we get $81 exactly. When 5 is C, we get $82.50. And when 6 is C, we get $84. Task time! Write the rule for this story. The entrance fee at Disneyland is $55 and going up every day. Churros cost $3. How much would you spend at Disneyland if you ate a certain amount of churros? So notice we're not giving you the amount of churros. You might have eaten 3, you might have eaten 5, you might have really pigged out and then vomited afterwards and eaten 13. We don't know. So we're going to use the variable C for churros. So think about what the rule would look like and imagine yourself in this situation. You can close your eyes and draw yourself walking through it. Write the rule for this story. You do not need to do a function table. We're just checking to see if you can get the rule. And you'll share that with your partners tomorrow.